Hi, I'm Michael Lane. I'm the president of LiftPort Group. I'd love to introduce you to my team, and thanks for being a part of the show tonight. Um, John, why don't you take it?
I'm Jonathan Connell. I'm some kind of an engineer. Been with LiftPort for I guess almost a year now, and I'm spending my time here developing simulations. I was born in England. I spent a lifetime in New York, and now I'm in Seattle making space elevators work.
Thanks, buddy. Appreciate it. Sean, go ahead.
My name is Sean Key. I used to be a banker, and now I'm working on the financial side of the space elevator and pretty much the commercial space industry. I do a lot of writing about it, which we'll go into detail later, and I actually produce a podcast about it, and would like to produce more.
Right on. Nice. Joseph, tell your story for a sec.
Hi, my name is Joseph Laran. I'm an engineering student at Penn State, and I'm originally from Washington State. So when I contacted LiftPort, it felt really nice to be able to come back to Washington and work with them. Here, I do a bit of engineering work, databases, and YouTube work, which end up actually being really important on our back end. Something that I really like about working at LiftPort, while I have a little bit of time here, I really like the creativity that it allows me as an individual and as an intern. I get a lot of freedom, and with that, they expect things in return, but I do get a lot of freedom to work here, and that is something that I really appreciate. The creativity, like I said, you're not just working on one little piece, you're working on a big scale here.
Nice. Very fun. Very fun. We're going to talk to Joe Luttrell and Ryan later on, but why don't you guys give a 1-minute intro for yourselves? Joseph, Joe Luttrell, go first.
Okay. Well, thank you, Michael. I'm Joe Luttrell. I'm the founder of a company called Cube, and we design micro-miniaturized electronics for space applications, primarily small satellites, but we also work in communications and delivery of payload to orbit. So yeah, that's us. That's what we do. We make things happen. We engineer and make things happen. That's what we do.
Love it. Love it. Love it. Ryan?
Hi, everyone. My name is Ryan Thill, co-founder and president here at Liam. So we're an AI company focused on enabling LLMs to reason over the largest and most complex data sets that we work with, and space is where we started. So we started building models to interpret X-ray data from Chandra, and then branched out to a pretty diverse set of data types now that we'll get into later.
Pretty neat. Pretty neat. So this is part of the team. I want to be clear that Lauren, Key, Connell, and I are the core team at LiftPort. Luttrell and Phil are contractors. We've got some other contractors that are going to be joining us later. Daniel Tompkins and Andrew Parlock and Wes Fairs. So got a good team. Things are starting to happen here. I'm Michael Lane. I'm the president of LiftPort Group. I'm guessing that if you're watching this show, you probably already know me, but the short version is started out in the Marine Corps, went to investment management, went to commercial real estate, and that's when the internet bug bit and started really getting into advanced technologies in my late 20s, early 30s. I started the first version of LiftPort all the way back in 2003. So I've been working on space elevators for north of 20 years, and this is the restart of the 5th attempt to build a space elevator for me, but I'm pretty sure it's going to work this time. So happy about that. What I'd like everybody to do, if they haven't already done it, is go to the bell and click subscribe on YouTube or LinkedIn. We have a newsletter over on our website at liftport.com. feel free to jump in and grab that. We have not actually published anything yet, but put your name on the list because it's coming. All right. And with that, let's go ahead and get into the meat of today's program. I'm pretty happy we teased it a little bit last month, but I'm pretty happy to kind of announce that we're building this thing that we call an industrial infrastructure network. As we've got the band back together and put a team together, started talking to clients and potential clients, what we realized really early on that is missing in the entire ecosystem of space is a unified community that can talk about what the community needs. So we decided to build out a chamber of commerce for space, certainly for the moon, but also the whole cislunar econosphere, from the ground of Earth to the ground of the moon, the regolith of the moon. That whole region needs to have a place that it can talk to each other. And what we're doing different, there are other organizations out there that do something. Open Luna Foundation does a great job. For All Moonkind does some cool stuff. The Moon Village Association, Moon Society, they all do good things. There's a really great group that Michael Castle-Miller is working on with the cooperative, Lunar Development Cooperative. They're all doing different things. And so we wanted to just kind of carve out a piece because what we found was the industry was just reinventing the wheel. And that's not a figure of speech. If you're a rover company, there's been a lot of rovers on the moon and Mars, but every rover company is basically reinventing the literal wheel for a rover company, for a rover. So what we decided was there needs to be this connective tissue for the lunar economy, a place where people who are building off-world infrastructure can find each other, coordinate, and let's face it, shake hands, do business together. It's important to note that this network that we're building is not a nonprofit. It's actually a product of LiftPort. We're considering spinning it out as its own separate corporation. We haven't made that decision yet, but it is a product of LiftPort. And the reason it is because we have skin in the game. We care about this ecosystem, and how it develops is important to us. If you're going to build an elevator on the moon, a transit system, and a space station, L1, and another station at Sinus Midday on the equator, you better be pretty good at working with other people. So that's what we're trying to do, is coordinate this stuff. We look at the actors in the sector: academic, civil, defense, and commercial. I call that ACDC. But we also don't want to forget that there's a lot of NGOs out there. So ACDC and N. And what we're trying to put together is this marketplace of tools and features. So there's the things that you need, the asks that you need of the community, and the things that you are offering to them. So it's an intentionally gated community. Membership requires at least one of these three things. You got to have 5 people. You have to have $250,000 in revenue, or you have to have $1 million in assets. Those are not negotiable. You have to have one of those. And you also have to pay a fee to be in the club. So it's $1,000 a month. That is intentionally gating, but it's a pretty low gate for folks who are trying to do something on the moon. So with that, I'm going to turn it over to Sean. And I want you to think about this one thing. Who do you know in the lunar development industry that should join our network? We're going to put links up here in a moment. Sean, go ahead.
Yeah, and piggybacking off what you're talking about with the network, I think you laid out what LiftPort does and what we're looking for. But then there's a big gap, especially like where is this product coming from that has to go to the moon? You start off in Seattle, ship it to Florida, be launched up to low Earth orbit, then catch a tug, go up to lunar orbit, and then down. We can bring it down. The only other options is to do that same process, very costly, and just blow it on up there to catch a tug and send it to the moon. The price points are very high, and LiftPort, we're very confident that we have a price point that can be competitive with anybody, including the big one down in Texas, Mr. SpaceX, and from bringing it down from L1 down to the lunar surface, and vice versa from the surface up to L1. Eventually over time we want to be able to bring stuff off. So, but we focus on that part from L1 down there to the surface. But we also need partners to come on to work, come up with deals and stuff, so we can fill in those gaps and complete this whole entire supply chain, this whole entire ecosystem. I mean, not only just the hard tech, we're talking about soft tech too. We're talking about insurance. Prime example. Insurance is very important. Insurance pretty much is going to help us figure out what the standardization is going to be. I can tell you that right now. That's one of the key drivers I see coming. I'm talking with a company that does non-equity debt for financing. They might be interested. And that's a very lucrative tool, especially for infrastructure. Folks, infrastructure is a very costly enterprise. VC capital is not really geared up for long-term infrastructure keys. So this is a very powerful asset to have.
Right.
I want to say that.
I know we got a siren going on. We'll just let it pass for a second. That's the fun part of being live.
Yeah. But yeah. There we go. All right, whoever caught it, thanks. But yeah, back to the network. It is a very powerful idea. It's even more powerful when people step up and contribute. You're going to have access to information. Sometimes you don't have to reinvent the wheel. And that's the part I like. You don't have to reinvent the wheel. Right. Folks, you're wasting a lot of time, a lot of resources, and a lot of effort doing stuff that you really didn't need to do in the first place, when you just can be a part of a network and have access to some of it.
Talk a little bit about standards. Why do you think that matters? What does a standard do for logistics? And you have a logistics background, so you should talk about that too.
Well, let's take an example, like a tug come to the L1 station. If we don't have the same hookup, how are we going to connect? That is a standard. That is a standard. If you're going to connect from Earth and to low Earth orbit, and you have to connect with a tug, how's it going to connect? It has to have the same type of connection. That is the standard. I personally like a universal connection because, in international waters, if something goes wrong, you have an obligation to help. And the same thing here. If something goes wrong in space, you have an obligation to help. But if you can't connect, the only thing you can do is tow, and there might be a catastrophe on board. That's the reason why standardization come in. Just like in shipping containers. It was whenever the military made the shipping containers come up with the standardization, the standard height to be placed on a ship, that's when global trade exploded. And I will also point out something. All these people that predicted where we're going, that's a very hard thing to do, because before global trade kicked off, nobody knew. Nobody knew what was going to be the next big thing. Nobody knew how the economy was going to evolve. They still don't know what's going to happen in space. But I guarantee you it will happen once we get more standardization and make it more repetitive and lower the cost and lower the risk. And that's part of the reason why this network is so important. Because more people come on, we agree to certain operating principles and the sizes and the structures and SOPs and procedures. We lower the risk of operation, which is a big key. We can repeat processes with lower and lower chances of deviations or a disaster happening. That's very, very important. And it boosts confidence from the economy, the Earth-based economy, into the space economy. And then especially when we can start returning products back, though, that's going to lock us in.
That down mass is one of your sweet spots. That's an area that you've always
absolutely been. I'm not the only one. I know. His name.
We're gonna be talking to Andrew Parlock here in a little while, specifically about Dan Mouse. So
Yeah, yeah, and down mounts is important because it closes that economic loop.
right on.
It makes it reciprocal. No longer is it are we sunken costs into basically an expedition. Now we have an economic chain going, and that's important. So
Right on.
yeah, and that's the reason why I see the network is very important.
Awesome. All right, we're going to bring on John to talk about the how of the network.
Thanks. I just disappeared, by the way. Sorry, I don't know what happened. Like, it never happens.
It's all good. It's all good.
You're on time.
No worries. No worries.
Okay, so the framing of this is stone soup to space, which is one of my fellow countrymen, Shakespeare, wrote a play around that. The premise is it takes a village to build a moon. Whatever company you're with the possible exception of one or two, you can't get there on your own. And the best you can hope to do is replicate the work of other companies, invest millions and millions and millions of dollars in developing equipment that somebody's already done, and wasting money and not getting there quickly. So the idea is that sharing of information, audited membership with very high walls, sharing of information, and controlled sharing of information. So if you're CMCC, you won't be able to give information to somebody else that isn't CMCC level 2. And you can decide who sees the print of your detumbler system. Typically, if you're designing a satellite and you want to get a drawing of that star tracker or a detumbling system, it takes a month. It takes more than a month. And you've got 2 presidents have to talk usually. And then finally you get a drawing, which you should have got 5 minutes before. We're trying to remove that delay to get that information. And again, it's a walled garden, so it will be secure and nobody else, you'll be in full control of what happens with your data and who you choose to do business with. So in the right way. So in addition to that, we hope to lobby and represent and initiate standards and generally push the industry in the right direction and assist groups of people to get to the moon and make the most of business on the moon. Further to that, we have some AI systems. We have 3 AI systems. We have Bike for Mind. We have Liam, one of whom's owners is in the building tonight. And we have Alexandria, which is our we have an AI that's consumed the entire output of the space industry everywhere for the past 60 years and learned it. So you can ask questions and you'll get access to papers that have never been seen before, because a lot of stuff isn't published, as you know. So we're helping to create the premier space resource of old data. And again, it's all been done before. And engineering hasn't changed. Technology's changed a bit, but the engineering's the same. It's good. The least you can say is it's good to look at how somebody else did it and learn from it and possibly emulate it. With Liam, we have a platform that will handle math very well. So it's if you've got a repetitive challenge like we have, which is stress in a flexible cable, we can turn that into a chunk of Python, sit that in the system. You can call on it in the future, and you can end up making very delicate simulations, very complicated simulations, and very accurate simulations with tools that you've assembled. We're hoping to have 100,000 files in that, and once we get enough people in there, we get the network effect. So it's not just about you and that guy you're interested in standing next to. It's the 50 other people who are talking to 50 people. And it becomes a tidal wave of information. And it becomes a real force to be reckoned with in the industry. And that's what we're looking for. To be an organization that helps you do what you do, that reduces engineering costs, helps engineering excel, and pushes forward the case to get done what we all want to get done on the moon.
It's pretty powerful. The more we look at these numbers, the more interesting it gets. So, yeah.
I think what we'd be interested to hear is what would you like us to do for that community, and what's needed. And we're here for you. So tell us what you would like to get out of that. If anything I said is a dumb idea, we'll talk about that. And I'm interested to hear what you've got, what would help you, because I know things would. Tell us.
Yeah. We'll talk more with John and Sean and Joseph in a bit. And we're going to get into some of the engineering that we're working on. I know that our fan core is really more interested in building a space elevator. So I don't really want this to be an ad for the network, but we think that the network is pretty dang important to building the elevator, right? We've all talked about it, and it's a pretty essential tool for this larger task. So we've done a lot of work on the elevator, and we're going to talk about some of the tools that we've created in that process this last month. But we're really trying to highlight this new thing that we're building. And I'm going to do a screen share and take you on a quick tour of the tool. We are going to, I want to make sure everybody's got the address. It's Noumenia.space, Noumenia. For those that don't happen to know ancient Greek, that means new moon. It was a religious holiday, one of the most religious holidays of ancient Greece. And it was the start and the beginnings of new things. It was the way to close out old things and start new. And they had this party every month. I kind of dig that. So we're calling it the Industrial Infrastructure Network. And notice, we don't even talk about it in the name that it's a moon-focused or cislunar space or satellite-focused or space anything network. It's an industrial network. We are trying to pull in everybody that needs to go. A couple months ago for April Fools, a friend of mine, Ron Wiener, made a post about 7-Elevens on the moon and being able to buy Slurpees at the bodega down the street. And he's like, if we have elevators, we can have bodegas. So he referenced us, and that was a pretty fun post. But the reality is, someone is going to sell duct tape on the moon. They're not ready to do that today, but we want to embrace that larger ecosystem, that larger culture. So, again, we're going to talk about academic, civil defense, and commercial. We're definitely very interested in bringing the finance sector into this. That's a legit push that Sean is bringing to the table. You can't do this without the defense and the civil sector involved. You certainly wouldn't want to do it if the academic sector wasn't involved. But it's going to be the commercial sector that drives this. Down mass, in-space assembly and manufacturing, tugboats, energy systems, data centers. All of that is going into the sky, and we want this network to be a part of it. By our internal numbers, there may be between 7,000 and 12,000 companies in this sector, and it's growing every year because the Artemis Accords and the nations, they're signatories to the Artemis Accords, are pushing their own lunar agenda. It's really quite amazing. So we want people to be a part of it. We're sick of this siloed innovation. We're sick of this scattered planning. We want people to be able to share. We've got Joe Luttrell on this call. We shared files with him. He shared files with us. We built a satellite faster because we shared information. That was really kind of the first real breakthrough that we had with that. This idea was a good idea. So that was months ago. We talked about it's not a nonprofit and it's not a trade association. We are trying to, earn money as a revenue source for the elevator. Now, is this revenue source big enough to build an elevator on the moon? Absolutely not. We're not trying to say that. What we are saying is pull the community together, put a little bit of a gate in there so that the folks that really are building infrastructure are the folks that are in this in the system. We are definitely Luna-centric and lunar orbits, but we would love to have folks in the satellite industry that are just going around in circles around the Earth. I mean, they're valuable partners, and we couldn't be where we are if they hadn't done what they're doing. This standards moat we think is really important. This network effect and this data moats. These are real assets. As John talked a little bit about stone soup, but it's the idea that if we all contribute a little bit, the whole community has a feast, and that's really kind of one of our core ideas here. It's not a pay-to-play environment. Being a gate is on purpose. But it's definitely hardware first. We want the folks that are building hard things in the sky. And then this member piece, I kind of think is a big deal. First of all, there's an application process. And the reason we're making people jump through these hoops, 5 people or $250,000 in revenue or $1 million in assets, this gate is structural, right? You want to know, if you join this thing, that the folks in the network are your peers, right? But this is a way that folks like Cube can sit in the same room as Lockheed Martin or Lunar Outpost, right? Which they don't get to do that often, right? So that's also, because we've been locked out. The early versions of LiftPort have been locked out of some of these systems, and I didn't want that in the system that we create. There is a process, set up an interview. We've got links here in the channel, but I'm also going to post my link to my Calendly account, so you've got that. And just come in and talk to us. Tell us what you're up to. There's a lot of stuff you get on day 1. There's going to be more stuff you get on day 7. There's going to be more stuff that you get on day 70. As more companies join the network becomes more valuable. It's the same thing that made AT&T a superpower. It's the same thing that's going to make this network work. One thing I want to point out here is the standards board that we're creating. That is pretty darn important. People are going to have to work together and figure out what the Lego connectors are between the systems. All right. Let me check time here. Do I have 2 minutes? Is that correct? Can somebody tell me if I've got 2 minutes or if I'm over time? I actually am not sure of that. We have a whole big back-end section. You're going to be able to adjust your board, what you're sharing with other people. There's a membership directory. We have 5 companies already in the system. There's 7 more that are pending. I can't name them, but you will all recognize the names when I say them. When you are in the interview, we'll tell you. If you're in the interview process, we'll tell you. But we're not going to say them online. But I will tell you, one of them is considering an IPO. They're big enough to consider an IPO, but they haven't run it yet. And one of their reps was in front of the NASDAQ offices today with a big rover. So that was pretty neat. And another one is working on asteroid mining. That is a name that you would all know. And another one is a refueling company that is a name you would all know. So we've got some pretty big folks that are flirting with us, and they haven't committed yet. We're going to talk to somebody that has committed later today, but I don't know if they're going to say it online. So somebody in the system has joined. So we're pretty excited about that. The content library is important. John already talked about that. That's going to be a huge thing. Being able to communicate across teams is important, and to other folks in the network. So with that, I'm going to stop sharing and come on back. Oh, I'm over. Damn it. That is not what I wanted. Thanks, Joseph. All right. Done with that. Wait, what is happening here? Stop sharing. There we go. All right, let's move on. I did not mean to go over. That's a little frustrating. All right, Ryan, you're up, sir. Did I go
How's it
over
going, Mike?
5 minutes? Did I really go over 5 minutes?
All good.
No, it's not.
You got the gift. You got the gift.
Joseph is just scowling at me on the other screen. All right, go ahead. Go ahead, Ryan.
Awesome. Well, yeah, Mike and LiftPort team, thanks for having me here. A little bit about Liam. We're about a 2-year-old company. As I mentioned in the intros, we started with this idea that, language models are incredibly powerful. Obviously, there's a ton of innovation that we all see in the AI world, but there are obvious limitations when it comes to the really large, complex, often numeric data sets that we use in the physical world. And so we started our research for about a year working with Chandra data, and trying to get language models to natively interpret that data and give physically meaningful answers and not just hallucinate. And we essentially abstracted up the patterns that we found in that research and built it into a platform that we call Liam, so that it is available to anyone who's a subject matter expert in their domain, who wants to do real data work in a way that they can trust and rely on the answers. And essentially, Liam's an AI platform that is collaborative and makes that easy for folks.
Love that. Love that. Talk about it a little bit about its history and its use cases and why math.
Yeah, so like I said, been around for about 2 years. We actually just officially launched a little over 2 weeks ago now and made it publicly available. We had it walled off for quite a while because Liam has a code execution environment and scalable compute in the background. So the user doesn't see that, but that's one of the things that allows us to work with, gigabyte and terabyte scale data sets. In terms of use cases, it's very broad. So like I said, we started in astrophysics working with Chandra data. We've gone multi-wavelength. The next step in bringing it down to Earth was, telescopes look out at space, satellites look back down at Earth, but it's very similar data. And so we do a lot of work with NOAA data, North Carolina Institute for Climate Studies, and some of the research that they do there. They're using Liam. And then, as we started to look across industries, we have a lot of subsurface use cases. Similar, very complex physics-based data sets, like a 3D seismic cube.
Underground, not underwater, right?
We have both, but primarily, subterranean, I guess you could say.
Okay.
So yeah, these are 3D seismic cubes, 10 to 100 gigabytes, low signal to noise, difficult to work with. And oftentimes you want to enhance those with other information like well logs that give you ground truth values and other things. So, Liam can actually work with the data, and we have a data set builder that'll help extract and essentially create materialized views for what you're looking for. We also have the ability to blend data. So when you're trying to take, going back to astronomy, it's like multi-wavelength data. I want to take optical, I want to take UV, I want to take X-ray, and combine that into, one feed for insights that I can get in natural language. Liam will do that for you. And then, the tools needed to work across these data sets in a reliable and repeatable way. We want to pull as much math out of the LLM as we can and build it into reusable tools so that they're reliable. So a bunch of use cases. I mean, when we launched, we've had thousands of people come in, about 250 people sign up, dozens of industries, even ones that we had written off, like healthcare. We thought, oh no, data's too sensitive. And then all of a sudden we have genomics data and blood samples. We've got a lot of interesting non-destructive testing use cases, semiconductor manufacturing, stuff like that. And then, of course, in the space industry, right? working with you guys. It was awesome getting to work with John on the calculations for the lunar elevator, and taking all the work that you had done and all the Excel notebooks and all the documentation that you had. And one of the great things with Liam is you can just point at that and say, hey, will you build this into reusable tools for me? And then that becomes the foundation upon which you can build additional tools that do further analysis, which is what we did for the lunar leg after you had already done the earthbound leg calculations. And so
I'm going to throw something in there because I think it's important. We tried that. We tried using some finite element analysis tools, and nothing would scale to the length of our system. We're talking about a 150,000 kilometer piece of string. Nothing would scale. There were no tools that would allow us to do that. We had to invent the tools and then use them, and Liam was a big part of that. So serious kudos to y'all for that. That was a hard problem that y'all cracked like super fast.
Yeah. And Ryan, we're also still talking about something about financial modeling too. That's another opportunity for you guys.
Yeah, absolutely. I mean, there are a ton of use cases just across finance that make a lot of sense for Liam, especially when it comes to combining financial data with real world data where you want to do analytics on it, right? Weather forecasting and how that affects the maritime industry, or maybe for you guys with launches, looking at some of the external factors that would affect the economics of what you're doing. And so, yeah, a lot of interesting use cases there as well.
Pretty neat, sir. Pretty neat. Okay, I'm gonna kind of, is there something else you want to talk about? Otherwise, I'm gonna kind of try to get us back on track. I shouldn't have got us off track. Nope.
No, good to go.
I want to point out, like, this is me, officially endorsing them. Go in, kick the tires, go test it out. If you like what you're seeing, Liam on its own is pretty badass. And then if you if you think that it makes sense to be a part of the network, that's actually going to be an even better system. We're going to have a white labeled system for LiftPort. It's going to be a bespoke tool that our community can use that's all focused on data, and they're going to be running that 100,000 file database as part of it. So Liam on standalone is pretty cool. Liam with the network is supercharged. So pretty happy about that. Y'all have been great. And again, another shout out, super responsive. We've got a back channel to their Slack team, and if there's a problem, they react. And they're also, when there's a new use case or we hadn't thought about that. Like, we ask for something and they're like, oh, let me write that down, and now it's a ticket. Now they turn it into a feature. So yeah, right on. Thanks a lot, Ryan. Appreciate it. Thanks for coming on. Enjoy your evening.
Yep. Thanks, everyone.
Good night. Bye-bye.
Yep.
All right, we're trying to get back on schedule. So Joseph Lauren, come on in. Let's kind of tighten it to maybe 3 or 4 minutes. 4 minutes.
Okay, I will try my best. First off, I agree with everyone. Liam is great. I've used it in an academic sense and now in a professional sense. I love it both places. For anyone who is looking for an AI, I truly believe that it will suit pretty much any use case, and I think that it is great. Moving forwards, I've used it in a few other AIs for projects like creating a library of our YouTube channel. It's 19 years old. It has a bunch of videos on it, hundreds of thousands of views, hundreds of hours of content, and there needs to be a back-end library for it. It's not glamorous work by any means. I'm sitting here in front of a computer working with AI to get this done as fast as possible. And a great way to do that is agents. That's something that we've learned as a collective group over time. Agents through Bike for Mind, Notion, Liam, any other AI. We really have learned it and how to put all that stuff together to get our tasks done correctly, but also efficiently.
And you had almost no AI experience and no
outside of
agent
schoolwork.
experience at all.
Outside of schoolwork, not a lot.
Yeah.
I've had AI teach me things before, but that's pretty much as far as it goes, to be
Cool.
straight up.
Talk a little bit about the harmonics class and your individual project.
So I'll start with the individual project. Up and coming in the next week or so, I need to find a project that is measurable, that I can get from start to finish, and I need to be able to do it and produce a product for LiftPort for them to go on, and it needs to truly be beneficial to them, because there's no point in me doing something that isn't beneficial to them. So as an intern, I do get that standalone individual hands-on work that a lot of interns do look for that don't get it. I know a lot of interns where their bosses will tell them go color in a coloring book for their whole entire 12 months or however long it is. And that's not what happens here. I actually get hands-on experience, and I'm really thankful for that. The engineering school, I work with John Connell, the lead engineer here, as I'm an engineering student. And we talked about what our challenges are, how we're going to address them, and just really how we get from point A to point B, what we've learned, any background we need to know before we go into this. And it's truly really helpful before talking with an AI or figuring out how we're going to set up these models to work. And I really talked about earlier how I'm personally getting hands-on experience. I believe that if there are any other students or people out there looking for hands-on experience, this is a great place to get it. Internships are internships. They're great to have on resumes, but what's better than just having an internship on your resume is getting hands-on experience. And this isn't a company that just accepts people from one area. This company has had people from Korea, Germany, France, Switzerland, the US. This is a great place for people to work. It's selective. I'll be straight up with that. It is selective. You need to have time. You need to actually put in your time. You can't just come work for 2 weeks or anything else, because that doesn't make sense to anyone. But if you have time and you're actually looking for something to better your career, this is a great place for it. If anybody wants to come work here in that capacity, you guys should reach out via the website at LiftPort. And yeah, I like I said, I think this is a great place. It's selective. You need to have time. Typically, they're not going to take first years, as you really don't know what you want to do yet. But going forwards, once you figured out what you really want to do, this is a great place.
Terrific. Thank you. Appreciate it. We've had more than 50 interns in my career that have come through our program, and we love them. It's remarkable how many amazing students come into our pipeline, and then they go out into the world and become amazing human beings. So we're very grateful to our pipeline of interns. All right. I am going to just super condense my ISDC recap. I went out to Washington, D.C. a couple weeks ago. It was by far one of the best events that I have done. It was great to see all my old friends. Joe Luttrell was there, and Wes Fares was there, and Daniel Tompkins was there. A lot of people that I already know, but really got to extend my relationships with people that and you're going to see some of those folks here on the show in the next show of the month. We made some, I believe, pivotal handshake deals. Now we're in the process of writing up contracts and paperwork. So hopefully I'll be able to talk about that next month. It was a really great show. Hats off to Tom Olson, who, as the director of the Center for Space Commerce and Finance, who sponsored us to go out there. That was really great for them. Appreciate that. Yeah, I'm gonna just yield back some of my time so we can get back on track here. Let's bring on Sean. Yep, exactly right. Well, let's bring on Sean and talk about better futures, clients, and reach, sir.
All right, I'd love to, but I want to piggyback on Joseph or Lorraine for a minute about being an intern.
Sure.
Working with AI and getting that experience is setting that young man up for his future. And if you're going to have an intern, get them experience behind AI. If you care about the future, you get them behind AI. Let them learn how to use it and optimize it and how to protect from bad information coming out.
Right?
That's key.
Yep.
That is very much key. But yeah, spot on. And that's kudos to Michael's leadership right there. But it's also it's great on him. I'm very proud of him. And I wish him the best as he continues on with us. But let's talk about better futures, which is what we all are here for, better futures.
A better future.
Anyway, so at Better Futures, I'm in charge of the media part. And let me pull up my notes real quick because unlike these guys, I'm on vacation. And
good for you. Seeing your son in sunny Las Vegas.
Yep. Okay. So with Better Futures, what we do, we produce podcasts. One of our flagship podcasts is with the very same director of the Center for Space Commerce and Finance, Thomas Olson. We produce the Unknown Quantity podcast, which is a podcast that's about the intersection of money in space. Great show. I recommend people to come watch it. It's about 30 minutes of news and 30 minutes of interviews with interesting people from around the industry on both sides, either entrepreneurs or investors, or money, or policymakers, but mostly those key parts right there, the money part. We have Daniel Tompkins on, who's going to be on the show tonight. That's been on the show before, and so has Joe. Joe, he can tell you some stories about us. Great guest. So that's what the podcast is, and we're working on discussing ideas. We've submitted to other companies about doing conferences. We're just waiting for feedback from them, what they're looking for exactly, kind of negotiation, the back and forth negotiations of what that could look like. And so hopefully we'll get some more progress there in the future. And so that's where we're at right now with podcasts. There is an open call. If you have a podcast idea, we would love to have it and see what we can come up with. If you're interested in being a sponsor, reach out to me and I'll be more than happy to see about getting you to be a sponsor for the Unknown Quantity.
Yep.
It would be a great spot for anybody who wants to get more eyes onto what it is that you do. So it's an awesome spot to be a sponsor. Or be a guest. Yeah, and that's another thing. Be a guest. We can never get enough guests. I thank everybody that comes on.
We do this show twice a week, Mondays and Thursdays. So we run through guests pretty fast.
Yes, and the quality's great. So yeah, think about it. Come on and be a guest. So that's the video side of it. The other side is the publishing side. I produce a newsletter called Better Futures Dispatch. Right now, I have 450 subscribers. And it's growing. It grows about 15 to 20 subscribers a week.
Yep.
So it's exponentially getting faster and faster.
Yep.
But it too, just like the podcast, it focuses on that intersection of money and space. I really target to people that are outside the industry with money who would like to come in. And I do it through I try to do it through a neutral lens, but I don't always come across neutral because of LiftPort. Right. And I'll get to that in just a second. But anyway, the newsletter is pretty popular. Dan Golden is a follower.
Who's Dan Golden again?
Former NASA administrator Dan Golden.
What? A former NASA administrator reads your newsletter? Wow, that's amazing. How's that?
And it's not because of my typing skills, it's because I have a good editor.
Right.
So, and I promote the newsletter and through LinkedIn. Again, same thing, sponsorship. You want to be a part of that. You want to get your word out there to people that have money who wants to invest in the industry. This is a great way to do it. So if you have a product out there that you need more exposure, come talk to us, me at Better Futures, and we'll find the right mix for you. There's a newsletter, podcast, a mix of the two. We'll do that. We'll work on something. We'll figure something out. So one of the key things I do use in the newsletter is I use a tier method, which is a topological structuring of the industry, and it's really basic concepts. There's tier 1, tier 2, tier 3, tier 4. Not tier 4. Excuse me, I got it backwards. Tier 0. It starts at tier 3, which is whiteboard. I have an idea. Tier 2 is development, which is what we're doing right now. Is development. Tier 1 is when you go into scaling, and tier 0 is when you're just pretty much the ecosystem. And speaking of ecosystems, which I'll get to in just a minute, this doesn't replace any kind of business financial planning, modeling, or anything like that. It is just an adjustment. And you use your standard business practices and financial models as you normally would. And you watch the risk levels come plummeting down as they go from tier 3, tier 2, tier 1 to tier 0, where you use normal models. You still use the normal models in this here. You just use an adjusted risk rate of return to track it and peg it to the tier system. You got the tier sector, which you can look at the tier ratio, which you can look at as 3 sectors. The critical sectors, whatever's upstream, which is the service providers that makes the critical sector what it is, and downstream, the beneficiaries of the critical sector. So when you look at the launch industry, space industry, that they quote like 600 billion, 400 billion of that is downstream.
Right.
200 billion is for the launch and upstream. So that 200 billion is what goes right into the space economy. The 400 billion is what's enabled by the space economy. And so that's something that is important. And if you see where investment's going heavy into the space economy, downstream, then you can see where there's bottlenecks bound to come. And now you know what the problems are. It's an easy diagnosis when you lay it out that way. So those are the two main things about the tier method that I use. There's a couple other things, but I'm going to cut down on time.
With just our last 2 minutes, one of the bottlenecks that you came up with, that you identified with the tier method, was spaceports and infrastructure. So talk about that for a second.
Oh yeah. Downstream is getting a ton of investment, and then upstream and the critical sector was basically, New Glenn really kind of showed it when it exploded. All right, if we lose a pad, we lose capacity, and that really got me started looking at, all right, what other options or spaceports are there? And also made me look at the financials of spaceports. Spaceports don't really respond to the traditional VC funding.
No way. They don't grow on trees. Nope.
Totally different game, folks. And so then, surprisingly, there's a lot of projects going on out all around the country, around the world. One going on in Kenya. I've actually, in the last couple of weeks since New Glenn, I have been inundated by spaceports companies who are interested in what I have to say.
Yeah.
So that's, and also maybe look at the financing models. And I had a financial firm that wants to look at non-diluted equity financial instruments for space companies. They really are targeting space companies. That's something coming along. We're actually going to have space insurance coming on to the show. They're key and pivotal to the development of the space economy, because if you, like Michael has always said, if you can't insure it,
you can't build it.
You can't build it.
Yep.
Well, if you can't insure it, you can't get a loan. Right. So that's important, folks. That's important. I'm really happy that they're coming. A few other things that I've been doing. I did write a couple of like economic development zone report that talks about the economic development zones, like for cisLunar, LEO, for Mars, asteroid belts, and all that. That was an interesting project. I just want to give kudos where I got the idea from. It was from the infrastructure network, because whenever we started talking about it, I started thinking about, all right, what do we need? What are these economic development zones that would help drive and foster an ecosystem that would make this possible? And ladies and gentlemen, I'm going to wrap it up real quick. We're running out of time.
Right.
It's the ecosystem that the network has and will create. Think about what SpaceX did. They didn't become a launch company that became the largest IPO of history. They became something different, and it was because of the ecosystem that they built. We can't build and match that, but we can build a network that can match that and people can use together. That is the importance of this.
Yep.
So I want to, I don't want to take it on more time. We got more people to come on. I tooted my horn enough. But again, think about the network. Hey, if you need to get your name out there, reach out to Better Futures or reach out to Michael or John or Joe. They'll get in touch with me. I'll be happy to come up with sponsorship deals. We'll figure out a package that works best for you. And thank you so much for your time.
Thanks, sir. I posted your Substack account in the chat so that people can follow your writings. All right, let's bring on John Connell. Sir, you got 10 combined minutes for 2 topics.
Okay, so let's talk about pull queues and bullwhips for a second. So we have a space, and at the heart of the space elevator is a very thin ribbon, a remarkably thin ribbon. The profile of the ribbon looks like this. So it's longer than it's wider than it's long, and it's very thin front to back. So we have that floating in space, and when we put a load on it or when we do something to it, the ribbon will move in space. Now, I said pull queues because one of the things that can happen with a polymer in space is if you hit the end of the pull queue, the pulse will go down the queue and hit a ball at the other end. And we call that a longitudinal wave. The bullwhip, on the other hand, would be a transverse wave, and we know what they look like. It's a wave running down the cable, looking like that. But there's something interesting going on. So we just worked out that the pull queue, the wave will be going down here. Transverse wave, this is the wave. There's another thing. I'm going to turn it around. You're looking at a wave coming at you. They can also be at this angle or this angle, and that's called polarization. It's polarization in mechanical systems. And what's really interesting is that there isn't a lot of work done on that, and certainly I don't think there's any work done on it in space that I can find. So we're walking on new ground, fresh footprints in new snow. So as has been said, we did what a space company does. We tried to make this work in FEA. And what we were told by the FEA companies is you can't get there from here because the problem is aspect ratio. The aspect ratio of that to 150,000 kilometers breaks the system. Our wonderful 18th century math was never designed stuff like that, so you don't get good answers. The best you can hope to do is slave a bunch of machines together and look at it. So we designed our own. Am I showing the, can anyone see my screen?
Not yet.
Okay.
No, I'm not seeing you. Because we really, here we go. Gotcha. All right.
Got it?
This love. Yeah.
Okay, good. So this is a view of the system that we we built us, so we couldn't do it with the standard tools. So we've started building a digital twin with high granularity. And I'm just going to run through it real quick. So these yellow blobs are 2 points in space. The moon's on the left, the Earth is on the right, not to scale. We're looking at local disturbances. And if we were to, I'm going to start one of these loads in motion here. And I started it with a ridiculous load. We're hoping to do like hundreds and 500 kilograms a month in a load. So you get, when you accelerate very quickly, you get a big pulse going down the ribbon. The essence of this project is to control the pulse that you release by moving something, and that's sort of intuitive. But there, in order to keep within the stress limits, we have to start and stop gently. So it's all about controlling your acceleration. Regardless of what your load is, you've got to control the acceleration. So that's called damping in the real world, and we know about damping. But there's some other clever things you can do. I'm going to start another load. Now, what I'm going to do, I'm going to polarize it slightly, because that will happen with a twisted cable. And I'm starting load 2 now. Load 2 is on the right there. If these were 2 carriers going next to each other, and a carrier sent a pulse out because it started too quickly or started too slowly, we would be able to send a pulse out from a neighboring carrier to cancel that wave. That's how your headphones work, noise canceling headphones. We could also have dampers on board each of our carriers, which would damp the vibrations. We also, there's a lot of variables in this. So part of our tether is going to be in sunlight. Part of it isn't all the time. So we've had to add ephemeris calculations. What part of the string, the ribbon, is in sunlight, and what part of the string is in darkness. We have to understand the speed that the wave will travel varies with the Young's modulus, and the Young's modulus varies with the temperature. So we have to do thermal simulations on this tiny little thread all the way along it. Well, it's in 2 gravity fields. It's in the moon's gravity field, and it's in the Earth's gravity field. And they vary. So we have to have that. But get further into it, there's more and more granularity you have to add to these things. And regulation is to say, don't do that, you'll break it. So it's defining the limits of possibility. We're looking at stress in the ribbon, and this red line here is telling us when it'll break. And these 2 were set up to cause a break quite deliberately for this demonstration. But that's how it works. So how many minutes did I do?
Pretty cool. You have... All right, you're right on track. You can talk about thermal flux, space school, not broadcasting, space school, and multi-body orbital modeling. So
okay, so the way okay, got it. The way we're handling this is I like my interns to do the work, because they're generally cleverer than I am, and they're more up to date on so many things. Particularly if you've got a bunch of them, they're going to be smarter than any older engineer. So I've set this up, or a version of this up, to be the base model system, and then I've handed it off to Joseph with a list of desirable features, and I've said, add them. Now we know that this needs to become a Python script, and we need to run a server, and managing the heat and the gravity it's some fairly nasty arithmetic. And we have to load, thank you, JPL, we have to load ephemeris from the net. There's a mission quality ephemeris to work out the temperature at any given point along this cable. And then it's massive differential equations simultaneous to solve the instantaneous load at any given point. And that's what we're moving towards. So we'll have a system that can stop any problem emerging before. Like if we had a broken cable, we could probably stop further damage by sending a pulse in the other direction of the same magnitude. So let the interns do the work. We have training every week. to bring them up to speed. Joseph knows most of what needs done, but I'm interested in getting thinking in a creative way about how we turn those basic ideas into practical ideas. And what I want for the guy is to get a capstone out of this, and I want him to get his name on a patent too. That's what we're shooting for.
It's because we think there might be a patent. We were going to broadcast this space school. We thought it would be really fun and interesting to our community to broadcast that. And then I vetoed it because there's some pretty interesting intellectual property that comes out of these conversations. So we won't be broadcasting those, but it's pretty cool. It's pretty cool stuff you guys are doing. Thank you.
There was something else I was going to mention. We've been looking at stable orbits. You know, we need to hang out at L1 for a long time. If we're parking things, we've found some very interesting low maintenance, low energy maintenance orbits between L1 and L2. Thank you, AI, which we think are really going to help us in keeping things where we want to keep them. So there's a lot of interesting simulation work going on at LiftPort right now. It's a lot of fun.
Right. Thanks a lot, John. Appreciate it. Joe Luttrell. See, that's never confusing. We've done that like 50 times, getting you guys all mixed up. Send emails to the wrong people. Send Slack messages to the wrong people. There's 3 Joes in our circle, and then my middle name is Joe. So Joe Luttrell, thanks for being here. Let's talk about small sats.
Yeah, no problem. Okay, let's see if this will let me share my screen. All right. Yep. So I just want to give a quick operations update of where we're at. It's been an interesting last few weeks, but things are moving forward. First, we did give this presentation at the ISDC.
I just need to put preface in is that we contracted y'all to build as a satellite for the world's first dedicated space elevator ribbon test. So that's called Fast Mover. You've been working on it for a while. We're really happy with it. So I just wanted to preface that. Go ahead.
Okay. So, met with a lot of folks at ISDC, gave this presentation, which explains a little bit about how CUBE got started. And it went over rather well. Got a lot of contacts out of that, and maybe some more business. That's always the thing you want. You want to keep the lights on, right? So what we build here at CUBE, we really work on miniaturizing things. It was mentioned earlier that the spaceports are bottlenecks. Well, what you can ship on a spacecraft or on a rocket is also limited. I mean, we're building bigger rockets, and that's nice, but the payloads seem to be getting bigger and bigger as well. But if you miniaturize those payloads, then you have the opportunity to launch more frequently and get more data back. It's just a matter of building it that way. So we spend our time building micro-miniature spacecraft. And when I say micro-miniature, some of these do fit in the palm of your hand. They're about 2 inches square. Okay. We've also worked out the API stacks to make this go. Full automated data analysis and a virtual operations center. But we also build stuff. And we build deployment systems. We're looking at solving a problem, the last mile, I would say, for communications issues. The RF frequencies are getting bottlenecked. That's another huge problem. We're looking at how can we make lasers work for communications for very tiny satellites. And when we say tiny, we're talking a laser module that weighs less than 100 grams. So lots of little tiny things that we're working on. And with that, we're looking to get about 1 megabit per second through that. Not the big stellar things you see from SpaceX, but for something, again, that weighs 2 kilograms, being able to use 100 grams for your communications module is, we think, the right sweet spot to be. And then, of course, our on-orbit payload operations. We do a lot of materials testing. We've built the unit for LiftPort. We're going to be testing the materials that can be used for the ribbon itself. And then ultimately in the future will lead to more tethered sort of tests. So this is the first in a series. This will be, as Michael, you have said, like watching paint dry, because we're going to be stretching these things and really putting them to task over the course of 2 to 3 years. This isn't a fast experiment, but it is a necessary experiment. And one of the things that is coming soon and in development, we talk about our tiny satellites. We want to go one better. We call them microsatellites, and we're not quite ready to reveal that yet.
Pretty neat
So,
stuff.
really, that's it. I mean, you know, thanks, Michael. I appreciate you letting us do this. It has been a total, complete blast for us.
It's been great. Talk a little bit about tracking, right? We've got to do telemetry. So our satellite is going to go up hopefully in November. There's been one pushback already. What's the plan for that? Where are we at with paperwork? What can we expect right now?
Okay. Well, the wonderful thing about rockets are that when the paperwork stack is as tall as the rocket, you get to launch. So think about that for a moment. Our spacecraft are actually smaller than the stack of paperwork we have to fill out.
Right.
We do have paperwork on file with the FCC, with the FAA, with the NOAA, and a host of other 3-letter agencies to make certain we make our window. Things are getting crowded. When SpaceX said they wanted to launch 1 million data satellites, I know that some folks at the FCC probably had mild heart attacks, right, because of the sheer volume of paperwork that will be. And everybody else, the small providers out here who know how the FCC works, we are having heart attacks because that type of system is going to bottleneck it even more. So we're glad we have our paperwork in. Hopefully we don't run into any problems with SpaceX or Blue Origin or any of the other big satellite constellations running roughshod over everybody else.
Is there a update on our flight? We're flying on InnoSpace out of Brazil. Updates with the provider?
They have transferred the rocket to Brazil. Last I heard was it was scheduled to arrive shortly. Once they have that, they'll start doing their checkouts. They've got a long way to go before they're ready for launch, but they're making the right moves and things look on target right now.
Okay.
How does separation work with that package you've got? Is it just like a Christmas tree like SpaceX, or is it spat out like a Pez dispenser, also like SpaceX?
We actually have our own Pez dispenser. Let's see if I can grab this without causing a huge mess like I did at ISDC. Remember that?
I do.
Oh, that was so bad. Anyway, this is our Pez dispenser here. This actually holds the satellite inside the frame, and it bolts anywhere on the spacecraft in the payload section that they'll allow us. Usually there's a lot of math, nothing like what you're doing, okay? But there's a lot of math into how to balance that rocket so it stays straight as a pencil. I've seen them put concrete in some vehicles in order to balance them. But yeah, we can bolt anywhere that there's space for that, and then they run a wire to the main control system, which is based on all open standards. And when they say go out the door, they push a button, the door opens, and a spring throws us out. I mean, it's super sophisticated.
Pretty neat here. We're going off of InnoSpace. Talk about their track record for our last minute here.
Okay.
Just so we set expectations, right?
Yeah. So InnoSpace has launched once, their maiden flight, and as is the norm for spacecraft, the rocket kind of had it went out instead of up.
Yeah.
Okay. Well, it went up partially, then it went out. That's a necessary mistake to make, and I'm glad they made it on their first flight because now they can analyze what needs to be done to fix it. If you get it right the first time, you don't know where the gremlins are.
Right.
Okay, they're working out the gremlins. This next flight is going to be, I think, a very successful one for them. I think they'll make orbit.
We do not want any gremlins on our flight. We're going up with your hardware. So you're setting up your own dedicated sats as well. So we're side by side with your system. So that's
we have some Earth observation satellites that'll be right alongside you.
Okay, right on. All right, Joe, thank you very much, sir. See you next month. See you next week. We'll talk again next week. All right.
Sounds good.
Thank you, sir. Appreciate it. All right. Mr. Dr. Tompkins, come on down. Daniel. Daniel. Oh, are we skipping Wes? What? Did I miss something? No, we're not skipping Wes. Sorry, it's not Daniel's turn. I misread that. My mistake. It's Wes's turn. Daniel, you come on in a minute. There we go.
Can everybody hear me?
Yep.
Cool. Well, I'll just jump right into it. My name's Wes Ferris. I'm a contractor now with the LiftPort Group. When it comes to securing and confirming property rights beyond national borders for space resource utilization. There's a good reason to this, and there's a reason that it factors all in. The space industry right now, especially the private sector, is spending a lot of time, resources, money on development of asteroids. It would be a lot more comfortable for everybody if everybody was secure in the fact that some form of rights can be executed on these areas that we're prospecting. I've been a boots on the ground advocate for private property rights in outer space. I'd say since the Bush administration, really, and it's at the time it might have been far-fetched, but there's always been a need for the past since 1967 to clarify the treaty framework surrounding celestial bodies. The Lynchpin Treaty was a disarmament treaty signed by the U.S. and the Soviet Union at the time, and now there's hundreds of other countries on board. Basically saying, one, no nukes in space, and two, whoever gets to the moon first can't annex it. So that forever closed off the options for countries expanding their borders into space. But it intentionally, very much so, left the concept of private property rights off the table. So nations can't make claims or have exercise any supreme political authority over any parts of outer space. But the concept of the development of the private sector was, for good reason, left off the table. Yeah. So at the time, you had two nuclear spacefaring nations at the table at the United Nations. Why include something like property rights, which the two are diametrically opposed on?
Right.
So the ambiguity really needed to be. It's set for a while. It really needed to be clarified, and there was a notion espoused that, well, since nations can't, if you're a part of a nation and the nation signed the Outer Space Treaty, they can't claim it. So they can't claim any property rights, and neither can you because you're a subnational entity. That explanation needed to be dealt with. So I put forth a test of the Outer Space Treaty. I, as a private individual, 2003, began the process of I registered a claim of ownership to the 3 stars of Orion's belt in order to seek out the competent authority. It was a stunt at first, but there was a background to it. So I selected those celestial bodies because they're light years away and there wouldn't be any controversy. I wanted to track down and get an answer from whoever I could get an answer from as to whether this can move forward or not. So the way I posed the question when I finally got to the competent authority within the State Department for implementation of the Outer Space Treaty is not it's not that I'm seeking clarification. I want you to define what the Outer Space Treaty says. I'm not asking for you to grant, quote unquote, grant me any kind of rights or any kind of formal recognition or other like military backing or any other endorsement. It's just a simple question of this claim documentation that I have. Is it is a claim by a private citizen in and of itself a violation of the Outer Space Treaty? I know they can't bang a gavel and grant anything other than that. So the least common denominator was I got confirmation that no, it wasn't. The way I phrased it was there are other treaties for territory beyond national borders, like the Law of the Sea Treaty for the ocean floor, and the Moon Treaty, which attempted to set up a regime throughout the solar system, have very specific terminology that deny property rights for individuals and private entities. So comparing with those two treaties and the lack of language in the Outer Space Treaty, I was able to get if the Outer Space Treaty had meant to exclude private individuals, it would have clearly stated so. This year, I'll fast forward. I've tried to come in from Orion and work my way in towards the solar system. Second set of claims was to do with the asteroid belt. I've tried once every administration, at least. I've tried to get the same confirmation through the same process.
That's an important detail. Once every administration for 20 years.
It's so like sometimes it'll every Secretary of State since Condoleezza Rice. So at first it's not a fluke. Like if I just said, hey, I got the answer I wanted with Orion's belt in 2009, and then didn't do anything, the next administration could have easily
could have reversed it, right?
But it's the angle that I'm coming at it from is that I'm asking them to do the least common denominator, which is just confirm that it can move forward by saying it's not a violation.
It does not violate. All right, so we got to wrap some of this up here.
Yes.
How many secretaries of state have you gotten documentation through?
This would be 7. So, all right. So and I want to explain why this matters. I'll share the screen.
Share the screen.
Not that the Secretary of State has ultimate authority over space.
Right. That's important. The Secretary of State, Rubio, does not have that authority over space. Even as high as he is, he cannot grant a claim. But once again, it's not a violation of the treaties.
Correct.
Are you sharing? Hold on.
There you go. I've done 2 tests, 2 additional claims this year. This one, I've taken it through a process called authentication for legal use abroad, where a legal document that's going overseas has a series of certifications and signature, like notaries upon notaries from county down to through state up to federal level. That a lot of documents that are required for international use. At this point, I'll go down and back up.
Scroll down a little bit so people can see the signature.
Yeah, so I'm going to have to force time to explain what this is and what this isn't. The Great Seal of the United States on this underlying document claiming ownership of an asteroid within the solar system. That doesn't. It prepares a document for international use, so I could take it to the competent authorities in different countries and do it and get the same confirmation. But it doesn't grant anything other than the fact that at this point they do look at the document. And they have to compare if anything in the underlying text is inimical to the best interest of the United States, or I think they're going to get in trouble by violating a treaty. This doesn't. They won't issue this kind of certification.
Right.
What's had to happen over time is I've had to get their office in touch with the actual competent authority, and the competent authority in the U.S. for matters pertaining to the Outer Space Treaty is the Department of State, Bureau of Oceans, International Environmental, Economic Affairs, and Space and Advanced Technology Division, which I'm happy to report my man Craig Autry has just of yesterday become the head of that office.
It's good to have friends in high places. All right.
Ask me anything that I might have skipped.
Yeah, I want you to scroll up to see the signature because I want people to know that that's a real signature. And I want to talk for 1 minute about this white paper because it's not just about getting the document. We also need to have backup and support.
I've developed a white paper, basically rationally explaining the status of property rights under the Outer Space Treaty. I'm trying to do that in a manner which nobody can really argue that without a doubt space property rights can move forward, and this is part of it here. It will be, I'll hear it through LiftPort eventually, but it takes it from the extreme of what you might first think of somebody trying to prove a point by making an outlandish claim, but it's really
very methodical step.
It's a rational piece that is kind of hard to argue with, and I want to come out of this with everybody on the same page about, like, yes, this is not a violation of the Outer Space Treaty. Yes, for so many different reasons, this can move forward, and it doesn't even require a new United Nations treaty to do that. I wish I had more time.
I know. All right, so I put your Space Rights LLC website up on the channel, and also I'm reminding people that our channel is here at liftport.com/contact, because if y'all are interested in submitting an idea or willing to be a signatory on this document, I think it's kind of important. So we'd love to see that. One thing I want to point out that John Connell said earlier today is, like, look, the whole world is investing money into these rocks and moons, and you want to make sure that this stuff is protected, that your investment in these things, that you are protected, right? We do not want this to be the wild, wild west. So with that, thanks a lot, Wes. Really appreciate your time and your scholarship. We're going to move on to Daniel, and thanks for hanging out. Enjoy your night.
All right, I'll take it. Thank you, guys.
Yep, bye-bye. All right, Daniel, sorry for the delay, sir. Appreciate your what is it, 9:30 out there for you almost. We won't cut your time. I still want you to get your 9 minutes, but I will cut a little bit of my time out of that so that we stay on track. So go ahead. What do you got? What's going on?
Sure. No, thank you for having me. I didn't catch too much previously. I had to run out and pick up the kid and get back, but I guess I'll share a screen here just to get that loaded.
Yep.
Slideshow. And of course, I can't see other people's reactions at this screen.
Right.
But that's okay. I know by your voice where we're going with this. So yeah, no, thank you for having me. And founder of Bromars, how to do kind of sustainable large-scale agriculture on Mars. And then just recently, we founded a company called Moondrops around large surface operations, particularly using multi-bases. so I guess I'll just jump right into it.
Mhm.
This is the basis of the basics of the idea. Having a base at the North Pole and South Pole, and doing everything in between is what's architecting this from the right. What does a whole of moon approach look like potentially? And this comes back to the doing traverses, is just that 14-day sunlit period. How far can you push a pressurized rover, and how much ground can you cover? Can you get from pole to pole?
Right.
And where this solves for is the logistics end of how to process your waste, how to pick up your resupply. I felt like the moon was about doing. You know, you can kind of grow on Mars, but to do everything that we want to do on the moon, how do we just go for it and do the whole of it? So I saw this as kind of a blind spot, and the numbers worked 3 years ago, and they're working even better today. So this is like another concept. This goes into a little bit more of the logistics around how it could work from a resource supply side, from the latest resource supply.
Daniel, say that last part again. You kind of faded out.
So this slide here represents how you can do some of that, drop off the waste, pick up your resources side at a low energetic cost.
Right. So
it's just real basics, not jumping into numbers or technologies or anything on here. And then specifically, where Michael Lane and I got talking about was the space elevator from L1 to 00. Is if you're doing one of these traverses, great reason to stop off in the middle as a resupply point. And it seemed like a good add-on. I probably wouldn't have pursued this without that understanding of what a space elevator could do for lunar logistics. So
yay, Lunar Logistics.
That's it. So I guess I'll just share those slides at the moment. But yeah, glad to have a conversation as well.
Well, okay, so let's kind of talk about this for a sec. What is it that you want to do up there, right? A base is cool. 2 bases is better. 3 bases, 1 in the middle, North Pole, South Pole, and us in the middle is better. But what is it that you want to do? Like, what set this in motion?
Yeah, so just the logistics around the solar power and in a rover, just that was hey, this is doable. This is not anything extreme. It's actually, the most recent calculations is it's the same max speed of the Apollo rovers. And now it's continuous, right? And it's solar powered, but it's not anything extreme. And the slopes are all there. The illumination is there. It's looking as we look deeper into it, the technicals work better, which is always a good thing. When you start off with pretty conservative numbers and expectations, and then you dial it down and you find some opportunities. So, I want to do the whole of the moon, because what I saw again and again was, a lot of the stakeholders being very science focused at the end of the day, science objective focused, and I saw this as just something that covered everything, everything from radio astronomy on the far side of the moon to doing all those traverses, picking up all those samples, to doing a lot of things in a lot of different places. This is outside the rocket equation. You could never pick up samples, right, over a long, traverse like this, right? Using rocket technology or any refueling architecture even would be really challenging. So yeah, I just saw this as kind of outside the equation. As everyone's kind of heads down, and saw that this as kind of as I've ground away at what commercial space will and will not do, and what NASA will and will not do. I've became uniquely aware of over the last 10 years of where kind of some of these potential blind spots are, technically and even kind of full picture. So yeah, it's an exciting one. Just less than 6 months from concept to funded study. So the funded study is taking a very hard look at the thermal elements of it and the logistical elements of it, and it's checking out pretty well. So
I want to talk about ROIs closing, because I got to tell you, that's not a common language in this field. It's a common language in our network, in our community, but it's not a common language in at NASA and some of the civil and some of the NGOs. So what's ROI mean to you, and what are you going to do?
Yeah, I mean, if everything works out well, conservatively, this is less than $10 billion in costs to get it minimally up and running. And the return on that would be substantial, I think, even just from the sampling, the digital data and the physical data, physically collected samples, there's massive value, I think, in there. And then operationally, it's a huge one as well.
So your starting point is $10 billion, but what's the end point? What do you do to get that end point?
Yeah, so a lot of steps from here to the 10 billion of executing, but the value there in being able to sustain, have humans in the loop in a very sustainable architecture, a very de-risked architecture that has a lot of national interest, being able to go past the Apollo sites, do platinum group metals, do helium-3 prospect, support helium. All the stakeholders. It's just how do you capture everyone and have a logistical system that can do so? Because if you can, why not do it?
Why not do it?
So that seems to be, where the value could be. And then how to do, radio astronomy on the far side of them, just logistically supporting that, getting to that side. If you have architecture that enables that, it's potentially unlocking, right? Oh, now we can do this, that, and the other thing, right? Is we can do everything that we wanted to and dreamt to do, and it's not hundreds and hundreds of billions of dollars. If you have this type of supporting architecture, you can say, hey, you know what? You can actually support like 2 people doing some serious work on the moon for less than $2 billion a year, which is a big thing, right? I mean,
okay, let me because we got to be good to our other guests here. Just really quick, I know that you had a pretty important meeting today. You were going to ask if you could share some stuff. Was that a yes or a no?
Yeah. So
right.
Yes, I can share some more details on that, particularly around the North and South Pole regions.
Share it fast. Share it fast.
South Pole is always of interest. The North Pole, because of the topography, looks like a great way to capture a lot of energy, a lot of solar energy, and operate there. It's kind of a blank spot. It's a white space right now, topographically. So that's looking increase as part of this logistical loop and concept of operations. It looks like that's a way that we can capture a lot of power to do this, that, and the other thing.
You're one of the few orgs that I'm talking to that's looking at the North Pole, and I think it's a missed opportunity. You have convinced me it's a missed opportunity.
Yeah, the numbers convinced me it was a missed opportunity because the South Pole is hard. I mean, and a lot of people will say this quietly around, in the science community. It's like, hey, we could do some of the science and we could do it easier. And there are options at the North Pole to do it as well. But everyone's like Shackleton, right?
Right.
So I think it's a good opportunity, especially if you're trying to do the whole moon. Especially, hey, we're up there already.
Whole moon philosophy. Like, I really want people to get that. All right, we got to cut you off, sir. I appreciate your time, Dr. Tompkins. Always fascinating to hear you. And is there, if anybody wants to ship something to the North Pole, you're the guy. So,
or from the equator to the South Pole, or from
right.
the North Pole, right? It's it can go both directions. The number of supporting both directions of operations. Cool. And very interested in collaboration on the thermal side. I think the thermal is a really missed opportunity. Really, we got to play in the same sandbox. The thermal sandbox has got to be equivalent. Otherwise, we don't really know what we're doing.
Right on. All right. Thanks a lot, sir. Appreciate it.
Thank you.
Thank you. All right, Andrew, let's bring you on here, sir. Sean and I are hitting the same button at the same time. Hey, hi.
Hey, guys. Dr. Tompkins was a great color guy for me. So Andrew Parlock, yeah. So I know Daniel. He's semi-local to me. I'm in Baltimore. So good to meet you, Sean and Jonathan. Andrew Parlock, CEO, co-founder. kind of idea guy at Space Phoenix. Listen, Space Phoenix wants to do one thing and just one thing only. We want to make all your lunar dreams come true, and that is, we just want to get you to the moon and get you back. That's it. We're not gonna get in the way of your elevators, but we're gonna help you build them. Daniel and I have talked already about getting his rovers onto the moon. But I will tell you that is the third stage of where Space Phoenix is. So want to talk about three things here. I'm going to share my screen. I didn't really have my technical slides with me tonight, and I apologize. So listen, this is who we are. This is our stage one, right? So Michael and I talked earlier today, and gosh, we've been talking
every day this week.
Yeah, I think we've talked 4 times in the past 5 days.
Right.
You know, here's the deal, everybody. We're building logistics. Okay, that logistics initially starts what I affectionately call phase 0, but the first step, and it's just building small spacecraft. These are about 220 kilogram spacecraft that'll get cargo agnostic payloads up to LEO and back to Earth. You know, that's phase 0. That's, to be quite honest, with all the really difficult things we're talking about tonight, that's kind of the easy button with all the difficult things we're thinking about tonight. But you know, I kind of, where are we heading? And I apologize for this slide. It's not the most technical and not meant to be. But phase 1 is we build the on Earth, the terrestrial infrastructure, and the permanence in space, unmanned stations, right? Because we got to have refueling stations. We've got to have the ability to get up, get back. And oh, Michael, you mentioned a dirty R word before, revenue, right? we got to have revenue. We got to have profit. You know, this can't be an esoteric science mission. The science has already been done. We know that. Like that's why we're all talking, because the science has been done. I agree with you, Sean. So, so phase 2 is a couple different levels, but it gets us permanence in space. I think I've got the customer to take the first step at phase 1A. We're going to be signing an MOU in November. We'll talk about what that looks like in a bit. I'm not really at liberty to talk about it right now, but phase 1B and C is just the expansion of unmanned infrastructure in space that we can use for whatever we want to use, right? So we're going to need data centers. We're going to need refueling sites. We're going to need docking stations. We're going to need all of this stuff. And we're going to need to bring stuff up to low Earth orbit, or even high low Earth orbit, low mid Earth orbit, or maybe even L1. I think that's probably a little too far out there for Earth. But we're going to need this infrastructure, and that's all we're doing, and to support all of this stuff. The next piece of infrastructure is phase 2, and phase 2 is really a cycler. Let's build a big craft that can get to the moon. That's it. Get to the moon, orbit, come back. Now, phase 2 has a couple parts that we have to prove out, right? First, we have to prove, can we do the cycler? I think that's relatively straightforward. Newton helped us there. But then we have to refuel around Earth, right? And if we're doing a cycler, we've only got about 75 minutes to refuel. So we have to rendezvous, refuel, and boom, we're back to the moon for about a day and a half to 2 day trip. Then we got to drop something off.
Let's be super clear to our audience here. That's why you're on the call, right?
Yes.
Cycler, because that is a missing piece of the ecosystem, right?
That's it.
You're the only person that's legit talking about a system, because we can't exist in the quote unquote vacuum of space. It's what we call the transportation stack. How do you get cargo from Seattle on a train
That's
down
it.
to
That's
Florida,
it.
take
That's
a
it.
dang rocket, get to VLEO, take a tugboat out to L1? Everything is a specialized piece, and if we don't master that Lego-like handoff,
Mm-hmm.
we don't get to build what we want to build. So
That's it. It's we got to build that railroad, and this is why I brought up phase zero. I call it phase zero on purpose because it's kind of the basics. Without phase zero, there just is no. It's the foundation,
no, right?
right?
Yeah,
But yeah, but phase one, to build out phase one with the unmanned stations and the structure that can be utilized in low Earth orbit, that really is key. Only then. Now, listen, we can test the cycler, we can drop stuff, we can do all that without the orbital infrastructure on Earth, but it's not going to be efficient. It's not going to be something that's reusable. It's not going to be something that really is sustainable, right? So, going back to the cycler, we got to drop something off. We got to pick something up. We got to allow people to land and then rendezvous. And again, one of the problems with the cycler is, well, going around the Earth, you probably have 100 minutes in the way the orbit works, and you could do a big old loop around the Earth. So you can modify the orbits, but around the moon, I'm a little nervous. I feel like that's gonna be really hard. Which is why, Michael, I think your idea of L1 is so important, because you've got stuff at L1, and chances are there'll be a refueling station at L1 as well, right?
right. Yep.
So,
Yep.
so I think there's a real opportunity. And the more I think about it, and I was talking to my engineers today, there's probably a service module that's kind of left in lunar orbit, and it
Right. Yep.
and it and it helps us, push and pull. It's a tug. It's truly a tug.
Right. Yeah.
Yeah. So
Well,
so that's where we're going. I
I-
think I'm over time already.
definitely Mrs. Parlick thinks you're overtime. So
Mrs. Parlock, we had our date night tonight. I'm on the East Coast here, so a little bit later out for you guys.
Yep.
A little bit later out for you guys. Yeah, but that's what we're thinking. So if you'll allow me, Michael, we're putting a lot more technical slides together.
Yep.
You're
on your way to Luxembourg to have a couple interesting conversations, and
yeah, we're on our way to Luxembourg.
we're going to be a part
Sunday.
of that slide deck. So we're
That's
grateful
exactly
for
right.
that.
That's exactly right. That's
Yep.
exactly right. Yeah, I'm going to Luxembourg, and the conversation I'm having in Luxembourg is not about Space Phoenix. It's about the partnership between what LiftPort wants to do on the moon and how Space Phoenix supports it. I'm done with these little isolated conversations. We've done pretty well in our seed round. It's now kind of time to open up the aperture a little bit and think about what this all looks like.
Awesome. Thanks so much for supporting us. We certainly support y'all. I'm looking forward to the day when you white label one of your transporters with our
Absolutely.
logo.
Absolutely.
I mean, I just got to say that's my ego talking, but I want to have our.
We're here for it.
spacecraft.
Listen, I said that to my team yesterday. I said, Amazon has its name printed all over the trucks, and you can't tell me what the truck is. You just know it's an Amazon truck, but Amazon didn't make the truck.
Right.
I'm fine with that. I got no ego in this. I just want to make it successful.
Right on. I really have enjoyed getting to know you over the last couple of months. Good luck overseas, and
No
we'll
doubt.
see you when you get back. All right.
You got it, gentlemen. Thanks for giving me the time.
Thanks so much. See ya. Have a good night. Bye-bye. Well, that is pretty dang exciting to me. That's pretty dang exciting. I'm not closing out yet, but as our guests are still on the screen, I just want in the background. I just want to do a shout out to them before they close off for the evening. Really do appreciate all of their knowledge, their time, their wisdom, their willingness to take on these big ideas. So you know. Ryan at Liam, Wes at Space Rights, Joe Luttrell at Cube, Daniel Tompkins at Moondrop, and Andrew Parlock at Phoenix Space Systems. We couldn't really do this stuff without you, and the whole theme of tonight's show has been around the network, right? Building this community, because you can't do this stuff on your own. You can't. It's impossible. So real sense of gratitude to all of y'all. Thank you. Appreciate that. I'm going to just talk pretty briefly about some reports that are going to go up on the website pretty much any day now. Some of y'all know that that we're pretty big fans of Peter Gerritsen, Dr. Peter Gerritsen, out of the think tank American Foreign Policy Institute. And which one is this that I'm doing? So we've got two. Wait, why is that happening here? Well, I guess I'll do this one first then. So he is taking. He's done a series. I'm going to stop sharing. I shouldn't have done that in the order that I did. He is doing a series of reports, and he finished one about a little over a month and a half ago, and it was focused on a really scary topic of what if you detonated a nuke on orbit. Timely, real. It's a real threat to the world. They named Russia as the potential bad guy, and it was one of the scariest things I've ever read, and I'm not kidding at all. Like, it is, to me, one of the scariest real world scenarios I've ever encountered. So that wasn't enough. He then went on and did a second report that came out about 3 weeks ago that was focused on railguns on the moon. And I'm guessing people on this show have heard Elon Musk talk about railguns on the moon. I'm very confident that he's going to have a railgun on the moon. Hell, he prototyped some of the earliest designs with his Hyperloop and his Boring company. So it's not like he hasn't telegraphed what his intentions are. So I'm very confident there's going to be a railgun on the moon. And Gerritsen's second paper talked about that. As a giant asset to the world, but also a very scary, spooky tool that, if it's used badly, could have a lot of consequences. It goes back to the old phrase that you can crush a skull or you can build a house with a hammer, right? It's not the tool's fault how it's used, it's the people. And he talked about that in his railgun document. And so his third in the trilogy is specifically about a lunar elevator on the moon. What can we do with it? Well, for one, it's pretty hard to turn it into a weapon, which I'm pretty happy about. But also the combination, the pair of elevators to softly, gently get you down to the surface of the moon and railguns to get you off of the moon, that is the ultimate virtuous cycle. Each of those things are powerful and good by themselves, but if you have both of them, each one is a game changer, and then it's game changer squared, right? So he asked us to put together a series of documents for his next paper. So what I've got, and now I'm going to share it. What I've got are two things. One is, what is the physics of our system? Because at the end of the day, most, I'm just going to like point out some of the topics. Well, it's a 56-page document. I'm not going to get into all of it. But at the end of the day, very few startups can claim that their defensive moat is physics, right? We get that, right? You've got two great big gravity wells. You got the Earth on one side, the moon on the other, and you build a ladder in between them, right? That's physics. Where you put this thing on the Earth side, on the lunar side, where it lands at the Lagrange point, that's physics. Our station does not require station keeping, which means every other station company is at an automatic disadvantage because of physics. We don't have to reboost our system because we're literally physically connected to the moon. We don't have to do reboosting, which is a giant cost savings and also expansive development. I believe, and I've said this lots of times, that when we build the NCC 1701 Enterprise, we are going to construct it not in Ohio, but at L1, right? So that's what this document is about. It's really the physics of the system that give us so many advantages. And, the idea that there can be only one, that, if you drop off the ribbon, you get a free return back home to Earth, or you get a free return back home to the moon, depending on which way is home. That it's a fort in the middle of at the top of two hills. You've got this lookout component there that the national defense is going to be really interested in. So that's document one, is to just describe as simply as we can a very complex system. It's pretty cool. It's definitely still in the rough draft stage, but I think it's going to be eye-opening. I think when I'm done, it's 56 pages now. I think it's going to be about 2/3 of that. There's more in here that's fluffy that I don't want, so that's going to go out Monday morning to Garrettson, and also the other one. The other one is this one is completely done. It's 19 pages. It's much tighter. It's kind of more the way that I'd like it to be, and it is specifically for what is the infrastructure we need for American space power. Like, this is for an audience, the think tank community in Washington, D.C. that is advising Space Force, Air Force, Army, Navy, Marine Corps, National Reconnaissance Office, the spooky side of NOAA, right? That's what this document's for. So, as a former U.S. Marine, I'm not going to apologize for that. Some people are not going to like the flavor of this one, but it is real, right? This is a real thing here, and I'm not gonna share the document because Garrettson wants us to, keep this stuff a little on the quiet side right now. And what he's going to do is he's going to take the pair of these documents and then put his own spin on it. So it's not going to be released in its current form. We'll put it up on our website once he's done. So he will get to see what we think. And then, as a former U.S. Air Force Lieutenant Colonel, retired, he's going to put his spin on our spin. So it might look differently than what we're seeing right now. But, we try to tell them about, look, there's a difference between a centripetal elevator, which is an Earth elevator, and a gravitational elevator, which is a lunar elevator, that it can be built now with current technology. One of the things that was particularly interesting was going back to Gerritson's first document, a nuke in orbit. Well, there's a lot of radiation there. Flying a new satellite up is actually not super effective because it's also dosed with radiation. Whereas if we could reconstitute that capability from outside the radiation zone from L1, that's a giant help. So with that, I'm going to close down. That is the evening. Really want to say thanks to my tremendous team, Jonathan Connell, Sean Key, and our much loved intern, Joseph Lauren. I'm Mike Lane. I'm the president of LiftPort Group. I love having your support. I'm really grateful to y'all for being a part of this. And thanks, y'all. Appreciate your help. Peace out.